This video has a few examples of using the Pythagorean theorem in word problems. This is from page 668, number 2 in our textbook. It says a square has a diagonal of the length of 12 centimeters, and then represent the situation with a diagram, and then find the length of each side of the square. So the first thing is I want you to know that a square has all equal sides, and then the diagonal is just from one vertex to the opposite vertex, and this distance is 12. We also know that a square has a right angle, and the Pythagorean theorem, which is the a squared plus b squared equals c squared. Side A and side B are the two shorter sides. In a right triangle, it's the two sides that make up the right angle, so we'll just call this A, and we'll call this B, and then we'll call the diagonal C. And so A equals B because all of these are congruent. Okay, so here's how we're going to use the Pythagorean theorem. If A equals B, we can let n equal the side of the square. N squared plus n squared equals 12 squared. From here, we collect like terms. It's 2n squared equals 144. Divide both sides by 2. N squared equals 72. And then when you take the square root of both of those, n equals about 8.49 centimeters squared. This comes from page 669, number 8. A painter leans a 25-foot ladder against the wall. The bottom of the ladder is 15 feet from the base of the wall. The painter then moves the bottom of the ladder 8 feet closer to the wall. How much higher is the top of the ladder? So we have two scenarios. We have the first part where the ladder is 15 feet from the house. So I'm just going to draw a picture. That's our house. Right here it says that the ladder is 25 and he leans it up against the wall. Okay, so here's our ladder and it is 25 feet. Okay, next it says the bottom of the ladder is 15 feet from the house. Okay, so from here to here is 15 feet. So do you see now that we have a triangle? It says how much higher is the top of the ladder on the wall? Okay, so to find that we need to first find out what this distance is. And we're going to use the Pythagorean theorem. We'll let 15 be A, the unknown height is B, and then 25 is C. So this 15 squared plus B squared equals 25 squared. It's 225 plus B squared equals 625. B squared equals 400, and B equals 20. So that is the original height when the ladder is 15 feet away from the house. So scenario 2, here's our house again. The ladder is still 25 feet, except this time it says the painter moves the bottom of the ladder 8 feet closer. It was 15 feet, and so 8 feet closer means that it's a total of 7 feet from the house because 15 minus 8 is 7. All right, so now we're going to do the Pythagorean theorem again, and we have 7 squared plus B squared equals 25 squared. This is 49 plus b squared equals 625. Subtract 49 from both sides, and b squared equals 576. Take the square root of both sides, and b equals 24. Now the question is, how much higher is the top of the ladder? It was originally 20 feet up the height of the house. Now it's 24 feet because think about it, if you move a ladder closer to the house, the top of the ladder is going to go higher. And so the answer to this question is 24 minus 20, which is 4 feet. This is page 669, number 11. Triangle ABC has the measurements of AB is 10 centimeters, BC is X, and AC is 12. What are the possible values for X? Now we need to know the theorem that two sides of a triangle have to be larger than the third side of the triangle. And so if we already know that one side is 10 and the other side is 12, that's 22. So that means BC cannot be 22 or greater. So we're going to say it has to be less than 22. Next, to find the shorter end, we're going to take these two numbers and subtract them. 12 minus 10 is 2. So BC has to at least be greater than 2 for this theorem to work. And so we can set up the answer as an interval. That means it has to be somewhere between the numbers of 2 and 22. And all we did was add the two values that were given to us and then subtract the two values that were given to us. Next, it says if BC is the shortest side of the triangle, what are the possible values of x that guarantees a triangle is acute? Now, for a triangle to be acute, a squared plus b squared has to be larger than c squared. So if we know AC has to be the longest, we can use the Pythagorean theorem to say x squared plus 10 squared has to be larger 12 squared. So the first thing we're going to do is we're going to go ahead and just solve for x. X squared plus 100 has to be greater than 144. X squared has to be greater than 44. And then x has to be greater than the square root of 44. So it has to be at least larger than the square root of 44, which is approximately 6.63. But we know two sides of the triangle. AC, which was the longest, and then AB is 10, so it can't go past 10 because the BC has to be the shortest side. And so it has to be at least the square root of 44, but it can't pass 10. And so we could say 6.63. X has to be larger, and it's not less than or equal to, it's just less than. 6.63 is less than x, but then x has to be less than 10 to remain the smallest. That's all for this video. Please let me know if you have any questions.